Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers in an online format, join our lectures. You can find the link to Discord in our Telegram channel. So, today we will talk about ternary search. This is the second lecture in our algorithms course. Accordingly, the definition of ternary search. Ternary search is a method for finding the minimum or maximum of a function on a segment which either strictly increases first and then strictly decreases or vice versa. Here you can see two examples. In the first case, the function first strictly decreases, then strictly increases. We can find the minimum of the given function. In the second case, it first increases, then decreases. It increases, then decreases. We can find the maximum of the given function. Let's denote this function as f of x. This function can be anything. For example, x squared or x squared minus the square root of x plus 2. In other words, any function that first strictly increases and then strictly decreases. Purpose. Used in computer science, computing, and mathematical programming. Step-by-step algorithm. Here we will consider only one of the steps, as the subsequent steps will be completely analogous. Accordingly, in the first case, we choose some points m1 and m2, which are, roughly speaking, at 1/3 and 2/3 of the given function, within the boundaries L and R, and we are interested, for example, if the extremum lies between L and m1. In the second case, the extremum lies between m1 and m2, and in the third case, between m2 and r. In this case, the extremum lies here. Accordingly, after determining where the extremum lies, we will work with these segments. And thus, with each step, we will reduce the complexity, here dividing for instance. Then we will also use m1 and m2 and take between these segments, similar to binary search but dividing into 3 parts. As m1 and m2 can be chosen within the segments, with m1 belonging to the range from L to the minimum, and m2 belonging to the range from the minimum to R, we similarly choose m1 and m2 as the centers of these intervals. Want to be accordingly sympathetic complexity. The best complexity of this algorithm is O of the logarithm of RL with base 3, logarithmic complexity with base 3, where RL is the size of the given segment. This complexity is achieved.
Want to become a great programmer? Subscribe to our Telegram channel.
In the case where the segment is divided into 3 parts, the extremum is located in the middle of one of the 3 parts. The worst case complexity is O of logarithm, RL, over epsilon, logarithmic complexity with base 3, where epsilon is the search precision. Accordingly, the implementation of this algorithm in pseudocode, where we are searching for some value, includes left, right, epsilon, and some function f, or it can be called the target, which is f. Accordingly, left goes from minus 100,000 and right goes up to 100,000, which are the boundaries of this function, and epsilon is 1e9, which means this level of precision for calculations. Since we have data types, if we take C++, these will be doubles, and they have a fractional part. For example, accordingly, as long as right-left is greater than epsilon, we check whether they have converged to a value less than epsilon, i.e., they are very close to each other. So in this case, we take the next step, determine mid1 and mid2. These are the given boundaries mid1 and mid2. We calculate them and check if f of mid1 is less than f of mid2, then right is mid2. Otherwise, if f of mid1 is greater than f of mid2, then left is mid1. Chaos. We will move either left to the right or right to the left. Accordingly, otherwise left equals mid1 and right equals mid2. We take the central segment. In the next step, we will take the central segment and we trim left to mid1 and right to mid2. We return the point mid1, since mid1 and mid2 will lie very close to each other. Again, due to the epsilon precision of the calculations, we can return either of them, as both will be correct. The exact same implementation of this code in Python, where the same points are defined, and all the same calculations are performed, is simply written in Python's interpretation. Accordingly, we also return mid1 here, and here is the implementation of this code in C++. Again, it is clear that the data type here is double, so we must define y accordingly. And we have a function f, which in this case is chosen for the example written as f of x equals x squared, and it returns x multiplied by x, which is the same as x squared. Here, you can write any function which does not contradict the rules of using ternary search. The function must decrease and then increase, or first increase and then decrease. If you do everything correctly, use this function according to the given rules, and implement it according to the provided codes, you will get the correct answer. Subscribe to our channel, leave comments, and stay tuned for the next lecture. Thank you all very much.
Want to become a great programmer? Subscribe to our Telegram channel.